All right, in this video, we are going to talk about a few different functions. You can have, if you have two functions, f and g, you can define the sum function. You can define the difference function, the product function, and the quotient function. It's pretty simple. We'll go through the definitions and then we'll do a couple examples of each, or one example of each, basically. Let's start with the sum function. If you have two functions, f and g, the sum function is defined by f plus g of x is equal to f of x plus g of x. The domain of f plus g consists of all real numbers x that are in the domains of both f and g. That is to say that the domain of f plus g is equal to the intersection, and this upside down u is the intersection. That means it's the domain of f intersected with the domain of g. In other words, it is all the x values that are in both the domain of f and also in the domain of g. So if there's a number that is in the domain of f that is not in the domain of g, it would not be in the domain of f plus g. Before we go over all of these different functions, maybe we should do an example for each one as we go. So let's go ahead. I am going to copy and paste this over to our OneNote, and let's explain what we mean by the sum function. So here we have f of x, which is equal to x squared plus 1, and we have g of x, which is equal to negative 3x. One thing I want to point out is that the domain of f is equal to all real numbers, which we express in interval notation as negative infinity to positive infinity. And the domain of g of x is equal to the set of all real numbers as well. Right? In both equations, I can plug in any x value and I will always get an output. Remember, in general, the main things we are going to look for that would mean that there might be some numbers that are not in the domain of our function would be if we have a square root or any type of even root, or if we have a fraction, because we cannot divide by 0, and so we'd have to avoid x values that could result in a 0 in the denominator of our fraction. All right, so according to our definition, f plus g of x is equal to f of x plus g of x. And so we are going to find f plus g of x, the sum function. And it's very simple. We're just going to replace f of x with what it's equal to, which is x squared plus 1. And we're going to replace g of x with what it's equal to, which is negative 3x. Now, if I do plus negative 3x, it's probably better. Remember, plus a minus is just a minus. And so it would be best to express like this. And again, I just want to reiterate, all I did here is I replaced f of x with what it's equal to, and I replaced g of x with what it's equal to. And then I simplified at the end. The domain of f plus g is equal to all of the numbers that are in the domain of, here, I'm going to do it a little bit differently. It'll be the domain of f intersected with the domain of G. So it's all the numbers that are in both. But in this case, the domain of F is just all real numbers, and the domain of G is just all real numbers. And so what numbers are in both all of the real numbers and all of the real numbers? Well, it is all of the real numbers. And so we are done. Next, we want to evaluate the new function for x equals 3. So f plus g of x, I'm going to start by just rewriting my function. And I'm going to plug in for x, I'm going to plug in 3. So everywhere I see an x, I'm going to replace it with the 3. And this is going to be 3 squared is 9, plus 1, and negative 3 times 3 is negative 9. And 9 plus 1 minus 9 is just 1. And we are done. Here is one thing I want to point out, and you don't need to do this if you see a problem like this, but I just want you to understand what f plus g of x actually is. If I plug in f of 3 would be equal to 3 squared plus 1, which is 10. G of 3 is equal to negative 3 times 3, which is negative 9. And notice that f of 3 plus g of 3 is equal to 10 plus negative 9, which would be equal to 1, which is the exact answer we got here. And that would be the case for any number that we plug in, right? If I do f plus g of 5, it'll be equal to f of 5 plus g of 5. And so what ends up happening is, and sometimes the reason that we do this is if we are trying to, this gives us one function that we can use and we can plug our number into instead of plugging in that same number into two different functions. So we end up with one rule that will always tell us what this, the sum of those two functions will be for any x value. All right, so that's the sum function. Let's go back to our slideshow and let's learn about the difference function. The difference function is very similar. If you are given functions f and g, the difference function is defined by f minus g of x is equal to f of x minus g of x. And again, the domain of f minus g will be the same. It'll be the domain of f intersected with the domain of g. So let's go through this process again. And let's find f minus g of x. And again, this will be f of x minus g of x. And then I just replace f of x with what it's equal to, which is x plus 1. And I replace g of x with what it's equal to, which is negative 3x. And notice here we end up with a double negative. Again, a double negative is the same as a positive. And so now we have our function. And our domain of f minus g is going to be equal to all real numbers for very similar reasoning as we followed up here. Next, let's evaluate this new function. For x equals 3. And so this is going to be equal to, well, first I guess I always like to start with the actual function with x. So I'm going to rewrite my function, and then I'm going to plug in x equals 3. So everywhere I see an x, I replace it with a 3. And this ends up being 9 plus 1 plus 9, which is equal to 19. All right. And I'm going to circle some of my answers from before. Okay. Let's go back to our slideshow and let's learn about the next two types of functions. There's the product function. If you're given functions f and g, the product function is defined as f times g of x is equal to f of x times g of x. So not surprising. And again, just like before, the domain of f times g will be equal to the intersection of the domain of f and the domain of g. I'm going to copy and paste. No, I'm not actually. Okay. So let's find f times g of x. This is going to be equal to f of x times g of x, which is going to be equal to x squared plus 1 times negative 3x. I'm going to put my negative 3x in parentheses, and I'm going to put f of x in parentheses as well. Now here I'm going to have to use the distributive property. So first I'll do negative 3x times x squared, and that ends up being the negative 3 will be my coefficient, and then x squared times x is equal to x to the third. Right? And I'll just write this off to the side in case it's not very clear. I'm going to do the same thing here. Negative 3x times 1, that's a little bit easier. That's just going to be minus 3x. And there is my function. All right, the domain of f times g of x is negative infinity to positive infinity, as all real numbers, again, for similar reasons as we discussed above. All right, now let's plug in x equals 3 and evaluate this function. I'll start with the function itself, which is negative 3x to the third minus 3x. I'm going to plug in for 3. And this is going to be equal to negative 3 times, and 3 to the third is 27. So I'll do the exponent first. And then negative 3 times 27 is negative 81. Negative 3 times 3 is negative 9. So this will be equal to negative 90. And that should make sense if you think about it, because negative 3 squared, if I look at this line right here, negative 3 squared plus 1 would be 10, because that would be 9 plus 1 is 10. And negative 3 times negative 3 is 9, so 10 times 9, or 10 times negative 9 is negative 90. All right, we have one more example that we need to go over, and one more thing that we need to talk about, which is the quotient function. The quotient function, if you are given functions f and g, the quotient function is defined by f divided by g of x is equal to f of x divided by g of x, where g of x is not equal to 0. Here the domain is a little bit different because here we have a fraction. So the domain of f of x consists of all real numbers x for which g of x is not equal to 0 that are also in the domains of both f and g. So the domain of f of g, it's basically the domain of f intercepted with the domain of g, but that also we have to basically get rid of any x values where g of x would be equal to 0. This will be easiest to understand when I do our example. So let's do our example. F divided by g of x is equal to f of x divided by g of x by definition. And I'm going to replace f of x with what it's equal to. And I'm going to replace g of x with what it's equal to. And that's my final answer. I can't simplify that. For the domain will basically be all real numbers because it'll be the intersection of the domain of f of x and the domain of g of x, which we already said is all real numbers. But we have to get rid of all x such that negative 3x, the denominator, is equal to 0. So we're going to take all real numbers except for any x value where negative 3 of x is equal to 0. Now to figure out when that's true, let's just solve this equation. When is 3x equal to 0? Well, negative 3x equals 0. I can solve this equation by dividing both sides by negative 3. And I get x equals 0 divided by negative 3, which is just 0. And that should make sense, right? Negative 3 times 0 is 0. So my domain, I'm going to express it actually a couple ways. In set notation, it would be all x such that x is not equal to 0. It can be any other number, but it can't be 0. Or in interval notation, this would be all the numbers that are less than 0, which we express like this, together with, that's the union sign, all the numbers that are greater than 0, which in interval notation we express like this. Finally, let's evaluate f over g of x for x equals 3. So again, I'm going to start with the function, and I'm going to plug in three. So this would be 3 squared plus 1 on top, negative 3 times 3 on the bottom. 3 squared plus 1 is 10. That goes on top. Negative 3 times 3 is negative 9. I can't simplify this. This is a perfectly good answer. All right. So I think that's it for this section. I hope you enjoyed the video, and we'll see you in the next one.